We know that the emergence of the computer has completely revolutionized the world, but the emergence of the quantum computer will be even more surprising. The computational unit used in the classical computers are called bits that are zeros and ones. Physically, zeros and ones bit are the low and high voltage states through a transistor in the computer, but the information unit or computational unit used in the quantum computer are the quantum bits that are called qubits. Unlike the classical bits, quantum bits exist in the superposition of 0 and 1 at the same time. Now, actually, the qubits are the different quantum energy states, and the particles they are associated with these different energy states depends on which type of qubit you used. Actually, different companies use different type of qubits for designing of their quantum computers. Like Google and IBM uses the superconducting qubits. In case of superconducting qubits, the trillion of the Cooper pair electrons are the source of these different quantum energy states. In the same way, the IonQ and the other company called the Quantum uses the trapped ion qubits. In case of trapped ion qubits, the ions that are trapped in the vacuum himself act as a source of different energy states. The another type of qubits used by the ITEL and the Silicon Quantum Computing Company in Australia called the spin qubits. And in case of spin qubits, the spin magnetic moment that are caused by external magnetic field in elementary particles like the electrons and protons are the sources of these different quantum energies. Now, here let me specifically focus on the superconducting qubits. In case of superconducting qubits, they placed a superconducting loop at absolute zero. Now, at absolute zero, the electrons in this loop form the Cooper pairs. Now, the question arises here is when we excite these electrons through any type of energy like the microwave, why these electrons not excites in the same way, like why they possess different energies or the superposition of different energy rather than having the same energies? Well, the answer to this question is because of the Josephson junction. They placed a small barrier of semiconductor in the superconducting loop, and that is called the Josephson junction. Now, there is a phenomenon in quantum physics called the quantum tunneling, and according to that, when a particle is on the one side of a barrier, if it has some energy, it can leak. The state of this particle can leak through the barrier even though it has not enough classical energy to overcome the barrier. So actually this Josephson junction leaks the states of the electron, leaks the energies levels of the electrons to the other side. So here the superposition emerges in the case of quantum computer. Another question is how quantum computer picks the most accurate answer among these states. Is there are millions of states through these loops. So how quantum computer decide the most accurate answer with 100% probability? Well, they use different type of the quantum gates and the quantum algorithms to figure out the most accurate answer. They used a circuit with different type of quantum gates called the oracle. Now the oracle flips the correct answer, like it changed the direction of the correct answer. After that, the Grover diffuser is another circuit with different type of quantum gates. It changed the amplitude of the correct answer. It uses the Grover algorithms, and that by performing the steps under root of n times, it increases the amplitude of the correct answer and shrinks the amplitude of the wrong answers by reflecting this amplitude with the average amplitude of these states. Let me understand the way classical and quantum computer works with an example. For example, you have the coins of different countries in a box, and your choice is to call for the US coin with the head. Now, the way classical computer will do it is to take each coin one by one and then toss it and to catch it to look for the head or tail. But the way quantum computer will do it is to toss all the coins in the box at the same time because it allows the superposition. Now, when the coins flipping in the air, it will calculate the probability for the correct coin, that is the US coin with head, using the quantum algorithms. When they perform these steps under root of n times on these coins, they found the US coin with the head, catch it and allow the other coins to fall down.